Hello JC Connect. So in this particular lecture I'll be solving a problem on tensile tension members. The problem given here as determine the tensile strength of plate 140 mm by 10 mm connected to 12 mm thick gusset plate using 24 mm dia bolts as shown in the figure. Use property class 4.6. So this is the problem given here, and also the figure is given. So this is the plate, this plate of size 145 10 mm connected to the gusset plate. Gusset plate thickness is given as 12 mm thickness. Just it is a lap joint. It is connected by using 6 number of bolts. Also the arrangement of bolts given, that is a chain bolting, and the pitch of the bolts given as a 60, edge distance 30, and the gauge distance is also given the 60. So let us write first the given datas. The data is given here as width of the plate is given 140 mm, then the thickness of the plate is 10 mm, diameter of bolt 24 mm, then the pitch there is a 60 mm given, edge distance is also given. So for the property class 4.6, property class 4.6 bolts, the ultimate tensile stress of the bolt becomes 400 Newton per millimeter square. Then this is the yield stress for the plate material, and this is for the bolt material. So plate material FUP will be 410 Newton per millimeter square. Then the strength of the plate, the tensile strength of the plate, tensile strength of the plate, the tensile strength of the plate is the least of that is the first one, strength due to gross area yielding, strength due to gross area yielding, or strength due to yielding, gross area yielding. Second, strength due to net section rupture, the third will be strength due to block shear, strength due to block shear. Failure. So this is strength due to cross section yielding, means TDZ, this is TDN, this is TDB. The least of TDZ, TDN, TDB will be the design strength. Least of least will be the tensile strength of the plate, this one, least of 3. Okay, so let us solve the first one. The first one will be the first one, tensile strength of plate tensile strength of the plate from yield consideration there is tensile strength of the plate from yield consideration. So we have a formula for that one. TDZ is equal to AZ Fy gamma MO, where AZ is the gross area of the plate, Fy is the yield stress of the plate material, and gamma MO is the partial safety factor. Okay, so here AZ is 140 into 10, we get 1400 millimeter square. Then Fy is 250 Newton per millimeter square. Then gamma MO is 1.1. So when you substitute this all, you will be getting TDZ as 318.18 kilonewton. So 318.18 kilonewton. So next is tensile strength of the plate. Next, second one, tensile strength of the plate from the consideration of rupture. Consideration of rupture along the critical section. Along the critical section. So here TDN will be 0.9 AN FU divided by gamma ml, where AN is, that is a net area at critical section. So here net area means this one, this will be the critical area, this section to be considered as a critical, this portion is a critical section, so section 1 is a critical. So along this, what is the net area? So here the net area will be AN equal to B minus N into DO into thickness. B is width of the plate 140 minus number of bolts along a critical section. Here how many number of bolts along critical section? There are 2 number of bolts along a critical section, so that is 2 into diameter of bolt is 24, but that is a diameter of hole, 24 plus 2, that is diameter of hole will be 24 plus 2 mm, clearance 26 mm, so 26 into thickness. So you will be getting minus 2 into 26 into thickness is 10 mm here, so you will be getting 880 millimeter square. Substituting in above equation, TDN, that is 0.9 into 880 into 410 divided by 1.25, so the answer you will be getting 259.726 kilonewton. This strength is due to net section rupture. Then third is strength due to or block shear strength. Block shear strength, that is TDB. Okay, so to calculate TDB, so we have a formula TDB1 and TDB2. So that I'll show in the code book. I'll show in code book, that is page number 32. So you'll be having a formula here. So I'll show you this one, these formulas. So you'll be getting TDB1 and TDB2. So please refer page number 33 of IS 800 2007. So you'll be getting a TDB1 and TDB2. So please refer this one, TDB1 and TDB2. The same formula I'll write here. So TDB1, that is AVZ Fy divided by root 3 gamma MO plus 0.9 ATN Fu divided by gamma ml. You will be getting, then this is of TDB1, then TDB2 is equal to 0.9 AVN Fu divided by root 3 gamma ml plus ATZ Fy divided by gamma MO. So this is the two formulas given in a code book. So now how to calculate AVZ and AVN. So here the failure pattern of plate in block shear, it will be like this. This is the failure pattern of plate. It will fail like this. Then here I'll mark this fail. And from the center of the bolt, this one is 60 and this is 30, this is 30, and also this one from center to center, this is 30, center 60. Okay. Then This is the failure pattern of the plate. Okay, so from this indicates from here to here is a length of shear plane till here, from the till center of the last bolt, length of shear plane. And this one, so from here to center here up to here, this is length of tension plane. So along, that is parallel to the load, this is parallel to the load, this is the shear area, this is shear area 1 and shear area 2. It has failed two sides, 1 2. Okay, perpendicular to the load, this one, length of tensile area. Then AVZ will be, so AVZ, I'll write here AVZ will be LV into thickness. AVZ will be LV into thickness into 2. Why to 2 sides? So what is LV here? So LV will be 30 plus 60 plus 60. So it comes to be 120 150. Then AVZ becomes will be 150 into 10 into 2 sets. So it comes to be around 150 into 10 into 2, 3000. Answer is 3000. Then AVN is net area. This one, net area, that is total how many bolt holes you have to remove, 1 2 2.5. So that is 150 minus 2.5 into 26 into thickness. 150 minus 2.5 into 26 into thickness into 2 sides. So what you get, 150, that is 2.5 into 26, 50 minus this into 10 into 2, you'll be getting 1700 mm square. 1700. Then similarly calculate ATZ will be this one, LT 60 into 10, you get 600 mm square. Then ATN, net area, so ATN means this one. So LT, that is the 60 minus 1 bolt hole, this side half, this side half has cut. So 1 into 26 into 10. So 60 minus 26 into 10. So 340. Get a 340. 340 mm square. Now substitute these all values here in TDB1 and TDB2. So you will get TDB1 and TDB2. So substitute values here. I'll substitute the values in TDB1. TDB1, that is AVZ, and AVZ will be getting AVZ 3000 into 250 divided by root 3 into 1.1 plus 0.9 ATN 340 into 410 divided by 1.25. So what you get answer here? Just calculate this one. 3000 into 250 then divided by the root of 3 into 1.1. So this term you get 393.64 into 10 raised to 3 and plus 0.9 into 340 into 410 divided by 1.25. You will get this one 100.368 into 10 raised to 3. Then you will be getting 393.64 plus 100.368, 494.00 into 10 raised to 3 Newton, that is TDB1. Similarly, calculate TDB2. TDB2 will be 0.9 into AVN. Calculate AVN into 1700 into 410 divided by root 3 into 1.1, sorry 1.25, root 3 into 1.25 plus ATG will be 600 into 250 divided by 1.1. The answer will be 0.9 into 1700 into 410 divided by root of 3 into 1.25. This one you will be getting 289.73 into 10 raised to 3 first term plus 600 into 250 divided by 1.1. Then you will be getting 136.36 into 10 raised to 3. Then the answer will be 289.73 plus 136.36 will be 426.09 kilonewton. This is TDB2. Therefore, TDB will be least of TDB1 and TDB2. Therefore, the block shear strength will be 426.09 kilonewton. Therefore, tensile strength of plate tensile strength of plate will be the least of above three values. Above three values. So we have to take the least of above three, that is TDZ, TDB and TDN. So we get TDZ is 318, TDN is 259 and TDB is 420. So least is the TDN value, that is 259.726 kilonewton. So this is the tensile strength. Okay. So the list of three, that is TDZ, TDN and TDB. This is the list of three, TDZ, TDN and TDB. This is the tensile strength of the plate. So this is the way to calculate the tensile strength of the plate. Okay.